On my last video, I built a simple rectifier that can output a maximum current of 300 milliamps and a maximum power of 3.6 watts. That very day, I wanted to build a project. Then I realized the voltage from my socket is less than 220 volts, meaning I can't solder batteries in series together to get 8.2 volts or 12 volts. Then I had a very bright idea.
I think I have an idea.
What if I made my rectifier output that voltage and serve as my battery?
Genius! Absolute genius!
In my current circuit, I utilized a regulator. And if you know anything about it, you'd know that it can output different voltages so far the input voltage is greater than the output voltage. This is thanks to this part of the IC. By changing the resistance value of R adjust, we can get different output voltages. Quick questions to my fellow engineers. Is there any device we know of that can vary its own resistance? If you guessed a potentiometer, you are right, and you are a genius like me.
Genius! Absolute genius!
By replacing my current R adjust with the potentiometer, we can have different output voltages. Now to the fun part. A bench supply consists of the following: a screen to display current and voltage, a power on button and an LED to indicate it's on, positive and negative output voltage or current terminals, then control knobs for current and voltage. This is the easy part. Basically, as I said, I just need to replace R adjust with a potentiometer. However, I need to add that a 220 ohm resistor should be placed in series with the potentiometer. From LM317 datasheet, it states that this guy outputs between 1.24 and 37 volts. So the 220 ohms sets our output to about 1.5 volts when the potentiometer is at 0 ohms. In my simulation, that works perfectly. Now for the hard part. Currently, I'll focus on voltage since that's easier to measure using a microcontroller. Luckily, I have a useless ESP-C3. Useless because no matter what I do, it never connects to Bluetooth or Wi-Fi devices. First off, we need to measure the output voltage from the regulator. And since we're using an ESP32 with 3.3 volt logic, we need a divider that can break our output voltage into something less than 3.3 volts. And then in our program, we can just multiply what we read by the ratio. So I chose R1 to be 10K and R2 to be 2.5K, so that the source voltage will be multiplied by 0.2. So for 10 volts, we'll have a voltage of 2 volts across the 2.5K ohm resistor, as seen in the simulation. Then in our code, read that voltage and multiply it by 5, which is equal to 1 over 0.2. And now we can successfully measure the voltage. You can see the link to that code in my description. Now for the display. So I need a display with less pins because of the ESP-C3 that can successfully display at least 2 to 3 digits. Luckily, I have this 4-digit 7-segment model. Okay, hold up, scrap that. It's way more complicated than I thought. I'm going to opt for this OLED display. Since I've got a good amount of experience, I just need to make some adjustments to the code. So now I got it to work. The issue I faced here was that initially I wanted to use this guy, but it was so complex because I've not programmed this before, and the stress behind it for such a small microcontroller with small pins is too much, because eventually I may want to solder this and I don't want the stress of having to deal with multiple pins like this. However, I also faced another issue. I wasn't connecting the other end of this potentiometer to ground, and I wasn't sharing the same ground with the microcontroller. And you might think, oh, does sharing the same ground with the microcontroller really matter? Well, it does, because the moment I remove the ground from the inverter, from the stuff, you can see it starts changing. This is the ground from the rectifier. So when I removed it, you can see this guy just keeps changing, 14, whatever. And when I include it back, we have a stable voltage. I don't know if you can see this. So we have a stable voltage, and now I can just change. You have 4 volts, and you can see the LED is getting brighter, 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 brighter because the output voltage is increasing. And yeah, this is very, very, very cool. Very, very, very cool. I won't even lie to you. This is so cool.
1 minute 37 seconds later.
Sadly, my bonds, the C3, probably a short circuit, but that won't stop me because with great mind comes great projects, and failure is also part of the process. So I guess for now, we'll be using my multimeter to display the different output voltages. So this is the circuit design I'm opting for. This is what I'm going to do on the breadboard, and this is how I want the entire thing to look like. Assuming the ESP hadn't failed, there will be a space here for the screen, but now that we don't have a screen, I'll just put an LED to indicate it's working, a button, as well as the knob, and then just a space here if I can. I'm not really good with cardboard, as you can tell, so I'll just try to make it look as fancy as it can, and then a plug, but for now I don't have a plug, so we're just going to go with what we have. We've got the complete circuit. Let's just, make a casing for it that is very beautiful. So I'm going to have to trim this away, and let's just change all of that.
Bit posh, isn't it?
The finished project is far from the design. However, I can still say I did a pretty good job. Now, we can vary the output DC voltage and power any circuit of our choice. I learned a lot from this project, and if you did, a like, follow and subscribe would be wonderful, as this video was not easy to make and took a lot of time and effort. To leave you guys with a quote: what's the use of your skills if you can't solve your current problem? This is Engineer Abiola, and see you guys in the next.